All right, ladies and gentlemen, we're looking at 11.2, trapezoids, rhombuses, and kites. We've already talked about the area of the trapezoid with our discovery lesson. So the area of a trapezoid is 1/2 the product of the height and the sum of the lengths of the bases. 1/2 height times base 1 plus base 2. Area of a rhombus is 1/2 diagonal 1 times diagonal 2. And the area of a kite is 1/2 diagonal 1 times diagonal 2. So these are more things that you should put on your vocab sheets, and we will probably tomorrow start putting stuff up on the board. Okay, so we're going to use these 3 different areas, formulas, to answer the next 6 problems. Okay, so we've got a trapezoid. My height's 4, one base is 6, one base is 8. Okay, so this is really simple. We just stick it into that formula. Sir, I had a calculator. Would you look in that box, Mr. Rainhurst? Okay, so I am going to simply put it in the formula. I'm going to say 1/2. What's the height here? 4. And I've got base 1 is 8 and base 2 is 6. So 8 plus 6 times 4 divided by 2 or times 1/2. You can do it in any order. Just make sure you put 8 plus 6 in parentheses.
So you can do 8 plus 6 times 4 and then you
Divide by 2. Yep. Did you guys get 28? So it's 28 feet what? Squared. So the free throw line on an international basketball court is shaped like a trapezoid. Find the area of the free throw line. Okay, so what is, again, we're looking at 1/2 height times base 1 plus base 2. Okay, so 1/2, what's the height? 5.8. Base 1? Base 2? So again, as long as you put parentheses around that, those additions, those bases, you should be good. So 1/2 times 5.8 times parentheses 6 plus 3.6. And we get 27.84 meters squared. How are we feeling about this? Pretty simple, plugging into that formula? Questions about this? Any? Okay. Let's move on to rhombuses. So we have a rhombus. One of the diagonals is 30 meters. The other diagonal is 40 meters. What's the area of a rhombus again? Diagonal 1 times diagonal 2. So it's 1/2, 40 times 30. So it's simply 600 meters squared. How do we feel about this? Pretty simple? Why don't you try the next one on your own? Raise your hand if you need help. we set this up, guys, what do I write? 1/2. And what do I get? I get 1/2 times 108, which is 54 millimeters squared. Good. All right, the next thing is a kite is the exact same setup. Oh, Miss Ruby cannot draw today. Or any day. Okay, so we've got my kite. This diagonal is 6 inches. The whole length of this or the other diagonal is 14 inches. Kite's the same thing, so I'm going to say 1/2, 6 times 14. So 6 times 14 divided by 2, what do I get? 42 what? Inches squared. Feeling okay? All right. One diagonal of the kite is twice as long as the other diagonal. The area of the kite is 72.25 square inches. What is the length of the diagonals? Okay, this is where I feel like it gets tricky. What's the first thing you should probably do if you have a situation like this? Draw a picture. Oh, gosh. Okay, we've got a kite. We've got one diagonal, and we know that the other diagonal is twice as long. We know the total is 72.25. So I know it's 1/2 diagonal 1 times diagonal 2 equals the area. So let's fill this in. I've got 1/2, I'm just going to put D1 as D. D2, I'm going to put 2 times D. Equals the area is 72.25. Okay. So, what's half of 2? If I took 0.5 times 2, I would get 1. And D times D is D squared equals 72.25. So if we divide that by 1, we just get D squared equals 72.25. And then we're going to take the square root of that. And we get the first diagonal is 8.5. How do we know what diagonal 2 is? It's twice as long. So diagonal 2, we simply multiply that by 2. We get 17. And I like to double check to see if I get the same answer. I'm going to go 17 times 8.5 times 0.5, or times 1/2, 72.25. All I did was plug that into my calculator with the plugging in D1 and D2 and made sure I got the same answer. All right, please take out your journals.